Hi friends, today we are going to see how to design a Butterworth digital filter and what are its procedure to go about. So let us take a problem for today. The problem says design a second order discrete time Butterworth filter with cutoff frequency of 1 kHz and a sampling frequency of 10 raised to 4 samples per second by bilinear transformation. And let us start its solution. To start up with, the order of the filter is given as 2 because they mentioned that it's a second order filter. So n is equal to 2. They are saying that the cutoff frequency, which is Fc, which is nothing but 1 kilohertz. And they are also saying that the sampling frequency f of s is 10 raised to 4 samples per second. So the complete specification that is given over here is with respect to analog frequency, and then they are asking us to design a digital filter. Now, to convert from analog to digital, the mapping technique to be used is mentioned in the problem as use bilinear transformation. So this has been stated in the problem. Now let us first calculate what is the actual cutoff frequency of this problem. So to calculate the digital cutoff frequency, so let us calculate the digital cutoff frequency. So the digital cutoff frequency is written as omega c, which is equal to 2 pi fc by fs, which is nothing but 2 pi into fc is 1 into 10 raised to 3 and fs is 10 raised to 4. So that will give me 2 pi into 10 raised to minus 1, or you can write it as 0.2 pi. So this is my omega c, which is 0.2 radians. Now, as we have found the cutoff frequency of digital filter, we will calculate the cutoff frequency of analog filter. Now there are two basic methods in doing this. First, either you can use this frequency and directly determine the analog frequency, or you can go via bilinear transformation method. So using bilinear transformation method, the analog frequency is given as omega c, which is nothing but 2 by t tan of omega c by 2. That will be 2 by t. Now t will be the sampling period. We know that the sampling frequency is 10 raised to 4 samples per second. Then t will be equal to 1 upon fs, which is nothing but 10 raised to minus 4 seconds. Let us put 10 raised to minus 4 over here. Okay, tan of omega c is 0.2 pi by 2. So you are going to get 2 upon 10 raised to minus 4 tan of, this will come as 0.1 pi. Okay, and the final answer of omega c as per the calculation is 6.498 into 10 raised to 3 radians per second. This is my omega c. This is one method. In second method, what you can do is, but both the methods will give two different answers, because here we are actually using the equation of which has been stated in the problem. Otherwise, one might also comment, let us say method 2, one might also comment that if fc is given as an analog frequency, which is nothing but 1 kilohertz, then the radian frequency omega c will be equal to 2 pi into fc, which is nothing but 2 pi into 1 kilohertz. which will roughly come to this value only, because this will be 2 into 3.14, okay, into 1 kilohertz. So that will also give me approximately equal to, because 3.14 is approximated value, so it will give me 8 and then 2.6 kilo radians per second. So we again have 6.82 kilo radians per second, and by this calculation we are getting 6.498 radians per second. So there is no much difference between two in this case, but both the methods are correct. Any one you can use. Either you can use omega, you can find omega c and then get the analog frequency, or you can use the given corresponding frequency and find the analog frequency. Now once we have obtained analog frequency, we can go for poles calculation. So let us find, let us say the poles calculation. So the poles in the Butterworth filter is given as pk, which is equal to plus and minus omega c e raised to, okay, e raised to j, okay, n plus 2k plus 1 by 2n, okay, with a pi over here, and here k goes as 0, 1, 2 and so on till n minus 1, because I started with 0. Now with this pole positions, let us put the value of k. Now here my n value is given as 2, so I will have 0 and 1 as the maximum value. So let us put p, k is equal to 0, so here k is equal to 0, so I get p of 0, which is plus or minus omega c into e raised to j, okay, n is 2, so I will write 2 plus 0 plus 1 upon 2 raised to 2 into 2, because n is 2. So we will get plus and minus, okay, omega c will be in this case, so omega c is 6.498 k, I write, because it's kilo radians per second, and e raised to j into 3, oh I missed a pi over here, so there is a pi again over here, 3 pi by 4. So P0, okay, will be 6.498 k into cos, okay, 3 pi by 4 plus j sine 3 pi by 4. So this is one value of pole, okay. So I have purposefully set it plus, because when I put minus I am going to get second pole, okay. Based on plus and minus values of this pole, let us say this pole to be plus and minus, okay, no problem. So I will have one PO to be 6.498 into k into cos 3 pi by 4 plus j sine 3 pi by 4, and second will be minus, let us say PO1 and PO2 will be minus 6.498 k into cos 3 pi by 4 plus j sine 3 pi by 4. Okay, so these are the two sets of poles now. So let us start with k is equal to 1. For k is equal to 1, I will have p of 1 which is equal to plus and minus omega c is 6.498 k, okay, e raised to j into pi, then I have n as 2 plus 2 into k, which is k is 1, so plus into 2 into 1 will be 2 plus 1 divided by 2 into n is 2, so it will give me value back this. So it will be plus or minus 6.498 k e raised to j 5 pi by 4 will be the value that I will get after product. So then I can write it as plus and minus 6.498 k into cosine 5 pi by 4 plus j sine 5 pi by 4. Okay, so once we have done with this, I will get P1 of two values. So again P1 comma 1 will be equal to 6.498 k, okay, into cosine 5 pi by 4 plus j sine 5 pi by 4, and P, let's say 1 comma 2 will be minus 6.498 k into cosine 5 pi by 4 plus j sine 5 pi by 4. Now let us evaluate both the poles by multiplying and finding what is the answer of this cosine and sine terms. So for P0 1, the value comes as if you multiply that 6.498 into cosine 3 pi by 4 will give me minus 0.707. So if you multiply it with now, it will be minus 4595.05 will be the real term, okay, and j, now sine pi by 3 pi by 4 is plus 0.707, so this will be plus again, and you will get 4595.05. This is my P01. Now for P02, my pole will be, I will bring the negative sign inside. So if I bring the negative sign inside, then it will be minus, okay, minus of minus it becomes plus, because cosine of 3 pi by 4 is minus 0.707, and outside minus will make it plus 4595.05. This will become now minus because sine 3 pi by 4 is plus 0.707 and 4595.05. Okay, this is P01. If I consider P11, again for the positive value, cosine 5 pi by 4 is minus 0.707 and sine 5 pi by 4 is plus 0.707. So I will get again minus 4595.05. Sine pi by 5 pi by 4 is minus, it's not plus. So cosine is also now minus and sine is also minus. So you will get both terms to go negative. So you will get minus j 4595.05, and P12 will be equal to minus 4595.05. Now it will not be minus because when I bring that minus sign inside, it becomes plus j 4595.05. Okay, so this is P01, P02, P11, P12, 4 values. So if I will plot them on a S plane, where I have this is minus sigma, this will be plus sigma, this is j omega, this is minus j omega. Okay, so now with this I will just plot random positions. We will not be up to the scale while plotting. It will be just 4 positions that I wanted to show that how the plot will look like. Now in this pole, this is my sigma and this is j times of omega, right? So let us plot the first value, minus and plus. So minus sigma and plus omega, that means that pole will be somewhere around here, minus sigma plus j omega, that is this pole. Okay, let's say this is P0, 1. Next is P02, which is plus and minus. So sigma is plus, this is minus. So it will come somewhere around this position because they are all of the same value. So let's say this is P02. Next is P11, which is minus and minus. So minus sigma and minus j omega, let's say it comes somewhere around here. So this is minus sigma and minus j omega, which is P, let's say 1, 1. And finally P12 is plus plus. So sigma is also plus, j omega is minus minus and plus plus, right? So that pole will come this is P12, let's say. So we have 4 poles on 4 positions, but according to the theory of control systems, we know that poles on the right hand side of the S plane makes the system unstable. So I will not use these 2 poles which are on the right hand side of the S plane because they will make the system go unstable. So I will use 2 values of poles which are P01 and P011. So I will have 2 poles which is minus 4595.05 plus J 4595.05, and second value I will use P11 as minus 4595.05 minus J 4595.05. You can see that both the poles are complex conjugate to each other, and that should be the case always. Now after finding P01 and P02, that are the 2 poles, let us find the transfer function. The transfer function H of S is given as omega c raised to n upon, okay, if the order is even, which is in this case it is so, but I will write first the generalized case. If the order is even, that is n is even, that time we will write the continued product of S is equal to let's say 1 to n minus 1 by 2. No, it will not be n minus 1 by 2. If I do n minus 1 by 2, then because order is even, okay, this will turn to an odd integer. For example, 4 minus 1 will be 3. So it will not be n minus 1 by 2, but it will be n by 2 minus 1. That will be the case. S square plus omega c s into bk plus omega c square. Okay, now for our case, for n is equal to 2, that is our case, H of S will be equal to omega c raised to 2 divided by, now the continued product will be S is equal to 1 to n by 2 minus 1. Now this should not be n by 2 minus 1 because the number of poles that we will have is 2. So it will be n by 2. So whenever it is an even ordered filter, then it will be always n by 2, not n by 2 minus 1. So now I will get s is equal to 1 to n by 2 will go to 1 only, which will be s square plus omega c into s bk plus omega c square. Okay, I have given continued product as s, so I should put here s, not k. S. Okay, if the continued product is s, then it will also change with respect to s. Okay, then now we can write b of s is equal to 2 times of sine, okay, 2k minus 1 or 2s minus 1 by 2n into pi. Okay, this is the value of bs. So it have bs is equal to 2 sine 2s minus 1 upon 2n into pi. This is the value of bs. Now let us solve the problem. The cutoff frequency for our case was therefore h of s will be equal to cutoff frequency 6.498k the whole square divided by s square plus omega c is 6.498k into bk, which I wanted to find, or bs, which is now in this case we have only one factor, that is b1 of s, plus omega c square, which is 6.498k the whole square, which will come as let's say 6.498k the whole square divided by, now my task is to find b1. So b1 will be equal to 2 times of sine, it was 2s minus 1 upon 2n. So because it is 1, I will have 2 into k as 1, so it will be 2 minus 1, that will be 1, okay, upon 2n, which is 4, and that will be pi by 4, 2 sine pi by 4. So it will be s square plus 6.498, this will be 2 times of sine pi by 4 into s plus 6.498k the whole square. Okay, so that is the transfer function of the h of s. So now if I solve this by putting all the constants and calculating all the values, h of s will come as 6.498k the whole square divided by, the denominator will look like s square plus 9190.1s plus 4.22 or 42.22 into 10 raised to 3. So that is a factor calculation according to my calculations. Okay, how you will solve this? We will solve this factor, multiply inside, this will give you this value. You will take the square of this, it will give you this value. If you are encouraged to also solve this and this will be the same, one and the same. So you can put this value here also, that's not an issue. This is not over. We want a digital filter or a discrete filter. For the discrete filter, we don't want h of s, we want h of n or h of omega or h of z, right? So what is the relation between h of z and h of s? H of z will be equal to h of s at s is equal to 2 by t 1 minus z inverse upon 1 plus z inverse. So replace all s's in the transfer function and you will get h of z. So my h of z will be equal to 6.498k whole square divided by s square will be now 2 by t 1 minus z inverse upon 1 plus z inverse the whole square plus 9190.1 into 2 by t 1 minus z inverse upon 1 plus z inverse plus 42.22 into 10 raised to 3 is the value of the transfer function. Now, if you wanted to solve this, you can solve it further by taking 1 plus z inverse common and t also common. That part you can do taking that into numerator, and then you can stop, because it will take a longer time for you to solve this further and get a proper transfer function of h of z in terms of negative indexes of z. So instead of wasting time, you can actually leave the part this much, or if you have enough time and the numbers are small, now the numbers are also very huge in this case. If the numbers are small, you can easily, if they are easily solvable, then you use this and then you go ahead with solving the problem. Otherwise, you can leave the problem at this stage also. There is nothing wrong in that. Okay, because the numbers are very huge, it will take a huge amount of time for you to calculate. So this is how we solve a problem. Just to summarize, we receive order, we receive cutoff frequency, and we have received the sampling frequency. Out of these given parameters, we have calculated omega c, which is nothing but 2 pi fc by fs. After that, we have calculated capital omega c by 2 by t tan of omega c by 2 factor. After getting omega c, we have calculated the poles. So pk we have calculated as omega c, this was plus and minus, okay, e raised to j 2n plus 2k plus 1 divided by 2n was the pole factors. After finding poles, we have written the transfer function h of s. For our case, it was omega c raised to n divided by continued product of s is equal to 1 to n by 2 s square plus omega c bs into s plus omega c raised to n, or omega square. Okay, that is our transfer function. Then we have converted the transfer function to h of z by just replacing h of z is equal to h of s as 2 by t 1 minus z inverse upon 1 plus z inverse. So whenever you get such problem, you have to follow this methodology. First, take the inputs, calculate whatever is necessary, and then find the poles, get the transfer function, find h of z. This is a procedure that we have followed in this problem. Thank you.